Now we move to part 2 of the Fundamental Theorem of Calculus. This is the part that gives us a fast and powerful way to evaluate definite integrals. If the function small f is continuous over the closed interval from a to b, and the function big f of x is any antiderivative of small f of x, then the definite integral from a to b of small f of x dx equals big F of b minus big F of a. This is the payoff of everything we've been building toward. Instead of approximating area or using geometry, we can now compute exact values using antiderivatives. You may also see this notation. This means find the antiderivative, evaluate the antiderivative at the upper limit, evaluate the antiderivative at the lower limit, then subtract. To evaluate a definite integral, first, we find the antiderivative. Second, evaluate the antiderivative at the upper limit and at the lower limit, and then subtract the results. Now, an important question comes up. What happens to the plus c? Let's see this in action. We want to use the Fundamental Theorem of Calculus Part 2 to evaluate the definite integral from 1 to 2 of x to the negative 4 dx. First, we start by finding the antiderivative. To find the antiderivative of x to the negative 4, we use the power rule. We add 1 to the exponent and we divide by the new exponent. So I have x to the negative 4 plus 1 over negative 4 plus 1 plus c. Negative 4 plus 1 is negative 3. So I have x to the negative 3 over negative 3 plus c. And x to the negative 3 over negative 3 is negative 1 over 3 times x to the third power. Now, I will evaluate this antiderivative at the upper limit and at the lower limit. When x equals 2, I have negative 1 over 3 times 2 to the third plus c. When x equals 1, I have negative 1 over 3 times 1 to the third power plus c. So I have negative 1 over 24 plus c minus negative 1 over 3 plus c. Let's distribute the negative side. I have positive 1/3 minus c. Notice what happens here. The plus c and the negative c cancel out. So we are left with negative 1 over 24 plus 1/3, which is 7 over 24. Now here's the key takeaway. We included the plus c this time to show what happens. But it always cancels out when we subtract. So when you evaluate definite integrals, you do not need to write plus c because it will always cancel out.